Binomial theorem. A plus b to the n. The binomial coefficient is n choose j. So the 1, 3, 3, 1, 1, 4, 6, 4, 1 is this guy right here. So it's n choose 0, a to the n, b to the 0, plus n choose 1, a to the n minus 1, b to the 1, n choose 2, a to the n minus 2, b to the 2. I think that's supposed to be a dot, dot, dot that turned into an L. Don't know why. N choose n minus 1, a to the 1, b to the n minus 1, n choose n, a to the 0, b to the n. Notice again, your coefficients add to 0, or your exponents add to 0 each time, which, not add to 0, add to n each time. So that n plus 0 is n minus 1 plus 1 is n minus 2 plus 2 is n. Here's the other thing that's interesting. The coefficient of the second factor, or the exponent of the second factor, is the number that appears here. The exponent of the second one is the number that appears here. The exponent of the second one is the number that appears there. That's an exceedingly important piece of information. So it can be stated in summation form as the sum from R equals 0 to n of n choose R, n a to the n minus R, b to the R, where n choose j is called the binomial coefficient. So here we go. You're going to see what a mess this is. Without Pascal's triangle. Pascal's triangle would make this so much easier. So here we go. Expand x plus y to the fifth. Now here, a is x and b is y. So it's the same game that we played before, except now we're going to have the binomial coefficients. It's going to be 5 choose 0, and it's x to the 5, y to the 0. This has to match that number down here. Plus 5 choose 1, x to the 4, y to the 1, plus 5 choose 2, x to the 3, y to the 2, plus 5 choose 3, x to the 2, y to the 3, plus 5 choose 4, x, y to the 4, plus 5 choose 5, x to the 0, y to the 5. Now here's my problem. I don't know what all those choosing things are. I don't know what 5 choose 0 is. I don't know what 5 choose 1 is. I don't know what 5 choose 2 is. I don't know what 5 choose 3 is. I don't know what any of these are. Pascal's triangle, I can tell you what they are. They're 1, 5, 10, 10, 5, 1. But we're raising it to the fifth power. That's what Pascal's triangle says. It says this should be a 1, this should be a 5, this should be a 10, this should be a 10, this should be a 5, that should be a 1. That's what Pascal's triangle tells me. So let's see. So here we go. And I need to find my choose thing. I am in math print, so makes life easy. So I will pull it off. 5 choose 0. 5, and I need to delete that. Choose 0, and I think delete that because I can't see. 5 choose 0 is 1. And let's do a couple of them so we can just work from there. 5 choose 1 is 5. 5 choose 2 is 10. I think we're going to do one more. 5 choose 3 is 10. So this is 1 times x to the 5th plus 5 times x to the 4th y to the 1 plus 10x cubed y squared plus 10x squared y cubed plus and now this is going to be 4, which is a 5. Which is a 1. So 5 x y to the 4th plus 1 y to the 5th. I like Pascal's triangle a lot better. I can get those coefficients quicker.
What's happening to get those values? Is it just doing Pascal's triangle, or is there...
No, what it's doing is this guy.
Okay.
N factorial divided by n minus r factorial. It's doing that calculation every time. Because that's what n choose r is.
Gotcha.
Pascal just makes it a lot easier.
Pascal just makes it a heck of a lot easier. You're right about that. I use Pascal's, as a student, I use Pascal's triangle all the time. You know, you could take it down to 6 without much trouble. And I didn't have to do that dang calculation every time. Or there are times I had to do it, like on the next problem.
It's such a strange, like, I guess, pattern that it goes up and then goes back down. I see why. It's just, it is strange.
But it's a pattern.
Right.
But math is patterns.
Yeah.
It says find the first, second, and last term. Now this is what you want to pay attention to when you finish this on Monday. The first term is 5 choose 0. We start at 0. The second term is not 2, it's 1. So it would be n choose 0, n choose 1 is the second term. The last term is n choose n. So you're always one number off in that second position. So when it says choose the first, the second, and the last, the binomial coefficient of 3x minus 4y to the 7, the first is 7 choose 0. It's the binomial coefficient. The second would be 7 choose 1, and the last would be 7 choose 7. Where A is 3x and B is negative 4y. So I'm just going to set it up for you. So the first term is 7 choose 0. Now, it's going to be 3x to the 7 minus 4y to the 0. 7 plus, because this has to match this down here. And then numerically you can calculate that out. The second is 7 choose 1, 3x, and if you're not sure, the one thing I know for sure is that the second factor has got to be to the 1 power, which means the first factor has to be to what power? 6, because I always have to add to 7. And the last would be 7 choose 7. Again, minus 4y has to be to the 7th because he's the last term. And the 3x has to be to the 0 because I have to add to 7.